In this part, we are going to talk about the tooling for milling. So, I mean, there is also another tooling for lathe operation and so on, but we are not going to go through. So we focus more on the tooling for milling here. So the first type of tools for milling, they call it the end mill. So I think we already see such tool previously in some examples for the G code when they say the end mill. So in the end mill here, we have two types, either two floats or four floats. So it depends on the difference in the hardness of the material for each type. Also, this type of end mill is plugging directly into the center of the solid material, suitable for rough drilling. Also, it is suitable to perform some of the whole operation like contour boring and boring, also cavity cutting. So as you can see in this figure here, there's the different type of the profile milling that we already mentioned before, like for circular profile, circular milling or circular profile milling, bucket milling, and so on. So this is the profile milling here on the figure on the top left side. And we have the two float and four float types, figure 318 and 317 here. For 317 is more on the four float type, and for the 318 is more on the two float type. And you can see what's the difference between the two types. As we said, the tool sometimes it has multiple operations. So I mean, sometimes we can use or we may use the tool for milling to perform milling, and at the same time, for example, perform hole operation, like to enlarge some of the existing hole for like in the pouring case and other hole operation process. So it depends on what is the, what is the operation that we need to perform. We have to select the suitable uh, tools for the milling operation in this case. This we call it the end mill. The second is the shell end mills, and the shell end mills, as you can see here, and this part is consists from the, this is the shell end mills, and this will be fixed on the, the spindle terminal to create or to do milling on the surface of the part. As you can see here, this part or workspace would have the, flat surface. Then we use this shell end mills in order to create such, it's like a bucket, but a bucket without two border on this side. To make it with, the thickness here of the workpiece becomes smaller than the original workpiece thickness. So to perform this type of the milling, we use the shell end mills. As you can see, the shell mill or the shell end mills, it has a bigger diameter, and maybe the feed rate here will become bigger because it will, depends on the size of the machine, of the tools, it will give you a bigger size. If we do this, we may do this milling operation by using other tools, like in the end mill case, like this one. But this will ask the spindle to go many times. We need to generate many of the coordinates in order to cover the whole area because of this type of machine with the, with the end, because of this end of this type of the end mills. But here, no, this will be rotate here, and this the part will, which is like this one, it will use to cover a bigger size or a bigger area for milling operation. Also, there is a carbide indexable insert end mills here. So you have, one tools, but it has some of the different parts here. Can be indexed inside the, at the end of the terminal of the tools. So depends on each part, it has different shapes, and it can reduce different milling operation on when it's work on the same. So this indexable here, that means it has on index for the different part of the material here, a different part of the tools, and this the whole one will be fixed into the spindle, and it will perform different operation based on an indexable or list to perform operation on the workpiece. This speed and feed rate, we already talked about it in chapter 4. I mean, you just go revise the same. So what is the definition of speed? What is the definition of the feed? So the speed is the relative movement between the tool and the workpiece, while the feed is the relative movement between the tool and the workpiece. But here, produce cut, and in this one is spread the cut. So in the for the speed here, it will produce the cut for the first part. Then in order to spread this cut, we need to feed. Feed, that means we are going to either move the workpiece towards the cutting tools, or the cutting tools will move towards the working piece. In both cases, this will result in the spread of the cutting process. We already defined this one, and here is the same formula that we have before for the speed with revolution. Here depends on the diameter and also the spindle speed over 1000. You have some exercise here you can go through, because you already have similar exercise in chapter 4 and in the assignment. You can just go through to confirm your result with this one. For the feed rate, also the same. We have the feed per tooth, which is millimeter per tooth, and we have the number of tooth, and we have the feed per minute. So these are the three different, variable or parameters that need to be considered related to the feed. And in order to calculate the feed rate, we are going to use the formula that we have already in chapter 4. Okay, so this is the same. Feed per minute equal to the feed tool number of teeth times the speed or RPM. This indicates, if you remember that formula was wrong previously, then we already modified it to be feed over tooth times number of teeth times the RPM. We have also exercise here already with the answer, so you just go through to revise the one that we have previously during chapter 4. Claimed and conventional milling here. So for the clamp and conventional milling operation depends by using such type of machine which move toward the workpiece. So this is the direction of the feed. That means we are going to push the workpiece toward the machine here, toward the tools, or another way we can say this tool will push toward the workpiece. So, in the case of the workpiece is fixed and the tools will move, or in the case of the tool is fixed, the workpiece will be moved on that direction. So there is two types. There is down milling and there is up milling. So it depends on the direction of the feed and the direction of the movement. This is the conventional one. We call it the conventional or up milling. That one is the clamp or down milling operations. As you can see here, the direction of arrow this way and the direction of the arrow in that way. So here you can see the direction of the rotating of the spindle with the tool is the same direction of the movement of the workpiece, and here the direction of the spindle with the tool is opposite to the direction of the working or of the workpiece or the direction of movement of the workpiece. Here is just more information about the clamp milling and which is the down or the up milling here. So less clamping here and horsepower is required. So this among the benefit from use this type of operation. When the spindle is rotating opposite to movement, so we need less clamping and less horsepower is required because there is a movement for the workpiece. It's on the direction of the movement for the tools or the spindle here. It is recommended in order to get more accurate roughing cut with the minimum machining marks, and also cutter are less prone to be dull, as there will be a table here. This table will compare what is the main differences between the up milling and the down milling. The direction of movement, the chips are progressively thicker. Here is thinner for the in the case of the down. The thickness of the chip is here is more thicker in the case of up. In the case of the down is thinner. Strong clamping is required here. Strong clamping is not required, because here the cutting force is directed upwards to the left of the workpiece. Here the cutting directed downwards and keep the workpiece pressed. So this table summarizes these two slides. I mean, about the main difference between the conventional method of the milling, I mean using the up milling, and also the clamp down milling. You can refer to this table to see what are the main differences. This used for hard material, this used for soft materials. I mean, the down is used for soft material, the up is used for the hard. CNC tooling, actually, there are two methods in order to change, or I mean, during the CNC operation, there are two methods in order to change the tools. As we see during when we use the G code last time, we mentioned for the automatic tool changer, and we said there is ATC for CNC machine, and this ATC, it has like index tools, and depends on the address, I mean the block of the coding in the G code, which talk about the type of the tool. When we say T1, M03, T2, T3, whatever is the type of the, I mean, whatever is the number or the index of the tool that we are going to use, so the ATC will change this tool automatically. That one is we call it the automatic tool changer. That means the machine itself, the CNC machine, will change the tool depends on their numbers. As you can see here, M06, T5, and M06, T7. Okay, so there is this number is used for indexing the tool inside the automatic tool changer. But there is another method also. As operator for the CNC machine, he can also change these tools manually. I mean, by using hand. As you can see here, the operator is come to fix the required tool with the required length. I mean, is it for drilling? Is it for hole operation? Is it for milling? Is it for lathe? So we will select the particular tool with the particular length and diameter, and it will fix it manually on the spindle. This is the manual method, and the one that will previously used with the NC machines. But for the modern CNC machine, they can use the ATC here, automatic tool change, in order to select the required tool based on the command or the block of coding in the G code here. Okay, so for the automatic tool changer here, it can like it has different types. So this type, we call it the drum type automatic tool changer, which is drum type ATC. So as you can see here, it looks like a drum, and there is a different tools will be placed in their specific places inside the drum, and each tool, it has its own number. So based on the code that provided in the in the G code, the number of the tool in the G code, it will be give the command to the ATC to give or to select the required tool for the specific operation. So this type of actually for holding small number of tools, that means it has limitation in terms of the number of tools, and it is not more than 30 tools. If the machines use such number of tools, so they go to use this type of the ATC. So it is stored, and also search for the tool is faster because it has like, it's in its shape, it's like circular, it's for rotating, so it can also, the number of tools is limited, so it can easily reach to the required tool. The second type is the chain tool. The chain type. So in the chain type here, it's kind of like this. They use the chain. So for the chain type, you have it has can be used for 40 tools and more. And it's this the chain here used to change or to rotate in order to rearrange the sequence of the tools. So the tool speed here search is less because we have more, more sets of tools, more number of tools, and also different chains. So we have to go like this: the first set, this the second set, the third set, and so on. So in each set there is a specific number or limited number of tools. So when the command or the coding come to the machine for specific type of tools, it should search in this large number or the tools in order to select the required tool. So this is the tool holder. On the ATC they use tool holder. On the Spindle there is a tool holder at the end. So tool holder means if I have drill, I need to fix on a spider twist drill. Um, I want to fix it on the spindle, so I have to use the proper terminal. Sometimes used for screw, sometimes used for cutter. So it depends on what is the tool that we are going to use. We need to select or the ATC will select the proper tool holder for the required tool. So the tool holder here need to ensure the accurate fit. So cannot use for this one, for example, if this one is designed for the spindle or twisted drill, so cannot be used for the other type of the drill or for the milling operation and so on. Another thing that we noticed during the when we talk about the G code, we see in some examples they write like coolant on, coolant off. Okay, so there is something they use that for cooling. During the operation they need to turn on the coolant or turn off the coolant. Why? Because during the operation of the CNC machine and during the cutting operation or drilling or hole operation, and due to the friction between the tool and the chip and also the workpiece that we are going to modify or to cut or to drill, the temperature will be increased. So when the temperature increase, this uh, will affect the tool lifetime. Maybe if this drill will be used maybe for 10 years in the normal lifetime, for example, without coolant, maybe it will finish within 2 years. So because of this high temperature, and this high temperature will affect the hardness and the strength of the material or of the tools. So for that, they use some of the liquids like fluids here. So the fluids will be used like oil, lubricating oil, and so on for coolant and for, with some chemical materials, soluble oils, for example, and so on. All these type of coolant they use during history in the CNC or in the NC machine previously. So why using the cutting fluids here? So these are the reason or the advantage of using the cutting fluids in the CNC machine: reduction of the tool cost, increase the speed of production, reduction of the labor cost, also reduction of the power cost. All these some of the reason um, that use or some of the features or advantage of using such cutting fluids in the CNC machines. As you can see here, if you have this is the shape tool interface. This is the tool. Here we have the workpiece and you have the chip inside here. So due to the friction, it will generate some of the area around the. When the tools meet with the or touch the workpiece, it will generate some of the area. In this area, actually, where the temperature will be increased, and due to the friction or the direct friction between this tool and the workpiece. For that, in such area, we need to have the liquid or due to or coolant to spray some of the coolant liquid to reduce the temperature in such area. So also it will help to produce good finishing for the product. Also to remove some of the parts which is still stick on such areas. So as you can see here, the heat generation, this more on the thermal operation of the CNC machine. And as you can see, the coolant here will have such pipe in order to spindle or spray some of the liquid or oil in or coolant materials. I mean coolant liquids in this place between the tools and the workpiece in order to reduce the temperature. By in the CNC machine, what I mean during the coding, yes, we have. I mean, when we change the tools, for example, or before, for example, as you can see in the example for the, I think for the whole operation or for the linear profiling, there is before you with the tool number one, we have the coolant on, for example. At the end of operation or the first operation, we have the coolant off. Then when we change the tool to tool number two, also we give command to the coolant to be on. Then at the end of the operation, the coolant will be off. I mean, depends on or the number of coolant on and off depends on the how many operations the CNC need to perform on the workpiece. So heat dissipation here. Ideally, actually, most heat taken off in chips, indicated by change in the chip color as heat cause chip to be oxidants. I mean, this is like what are the impact or effect that will be produced on the chips and also on the cutting tools due to the increase in the temperature. Sometimes you, as you can see, if the temperature is go very high, that even the color of the I mean the color of the material, I mean of the chips will be changed. It's become more because due to of the more of occidental effect on these chips. So the cutting fluids here will assist to taking away the heat. Also can dissipate at least 50% of 50% of the grating during the machining. So I mean the cutting fluids here will lowering the temperature by at least or the heat by 50%. These are the characteristics of the good cutting fluids. So it's good cooling capacity, good lubricating quality, resistance to rancidity, relatively low viscosity, stability also, and also rust resistance, non-toxic, transparent, are also non-flammable. So these are some of the characteristics to compare between different or uh, to select the good cutting fluid for the for specific CNC machines. I mean, based on this parameter, they go to prefer the preferable will be taken over to select among different type of the cutting fluid. These are the type of the cutting fluid here. Most commonly used cutting fluid fall into three categories: cutting oils or emulsifiable oils or chemicals. So the chemical cutting fluids. So these are the three main category for the cutting fluids or that use with the coolant system for the CNC machine. And here is the oil categories. Depends on, I mean, more on the chemical construction, light color, stain cover, and alloys. I mean, this more on the chemical features of this oil, actually, just to show the different type of oil categories that use for the with the coolant in the CNC system. So it's like show how many the percentage of the sulfur, how many the percentage of chlorine. It's more on the chemical operation. You are not required to go in depth of these things. Inactive cutting oils. Oil will not darken cover hair for the specific temperature of 212 Fahrenheit in during 3 hours. So it's contained sulfur in is natural hair in such type of inactive cutting oils. Also four general categories will be under this inactive cutting oils. I mean, just for this one, just read it for your information about this category of the and function of the cutting oil here. So the function of the cutting oil is prime functions is provide cooling and provide lubrication. So these are the main function for or primary functions of the cutting fluid in the CNC machine. Other function here, I mean like side effect or it's not side effect, it's like add-on functionalities, prolong the cutting tool lives, provide rust control and resist rancidity. I mean, the main aim of using such cutting fluid here is to perform the cooling or the cooling for our system due to the friction and the high temperature in the CNC machines. It's actually not the machine itself, but the place of um, friction between the tool and the workpiece. So for the cooling here, the part for the cooling here, heat has a definite bearing on the cutting tool wear, so small reduction will greatly extend the tool lives. This is what the cooling will do with the tool or with the CNC tooling. It will increase their life because it will reduce the heat or the temperature that will be produced. There is two sources of heat during the cutting action here. From where the temperature is come, for the first plastic deformation of metal, and the second is friction from chips sliding along the cutting tool face. So this is the main reason to generate the high temperature in the during the cutting process in the in the CNC machines. Water is most effective for reducing heat. I mean, maybe the water also can be used. I mean, in addition to the cutting fluid, like I mean the oils, also water can be used to reduce such type of the temperature or such type of heat. For the lubrication here, because we said the main primary here is cooling and lubrication. So for the cooling, these are the what is the result or what is the benefit from use cutting fluid for cooling, and here what is the benefit from use cutting fluid for lubrication. So it will reduce the friction between the chip and tools. So shear plane becomes shorter. Also area where the plastic deformation occurs correspondingly smaller. So I mean when the two or the tool is touch or meet with the workpiece, there will be like some plastic or formation as we can see here, as we mentioned here. That means there is like a layer of plastic will be performed, and this layer of plastic that will be performed um, will be smaller due to the use of lubrication. Okay. So extreme pressure lubricant reduce the amount of heat producing by friction. This is also one of the benefit for using lubrication. Also, chemical fluid here combined chemically with shared metal of chip from solid compound. So allow chip to slide. Since it is lubrication or oil, it will allow the chip to be slide smoothly with the workpiece and or between the workpiece and the CNC tools.